Mascot Server 3.0 is a major feature release. The first big change is how machine learning is applied. Like earlier versions, Mascot ships with Percolator, which uses semi-supervised machine learning to improve the discrimination between correct and incorrect spectrum identifications. We call this refining the results with machine learning. Mascot Server 3.0 can now use predicted retention times. The difference between predicted and observed retention time is passed to Percolator, which boosts the score of correct identifications. The predictions are provided by DeepLC, which uses state-of-the-art deep neural networks. Mascot Server 3.0 can also use predicted fragmentation spectra. The correlation between predicted and observed spectrum typically gives a further boost to correct identifications. The predictions are provided by MS²PIP, which is trained on hundreds of thousands of MSMS spectra. The machine learning workflow has been simplified. Select DeepLC and MS²PIP models directly in the Mascot search form, and they are passed through all the way to exporting the results. Mascot Server 3.0 includes a brand new machine learning quality report. This helps answer questions like, did machine learning improve my results? And if so, how much? Machine learning isn't the only improvement. When you submit an error-tolerant search, you can restrict the second pass to selected modification classes. This makes the search faster and more precise. The user help shipped with Mascot has been thoroughly reviewed and updated. We've added dozens of new help pages and tutorials that cover all aspects of peptide and protein identification and quantification. Mascot Server 3.0 introduces a new file format for search results. This change improves the read performance when browsing the results interactively. And Mascot Server 3.0 also includes Mascot Daemon 3.0. Let's look at machine learning in more detail. Mascot Server 3.0 integrates MS²Rescore, which is a modular and user-friendly platform for AI-assisted rescoring of peptide identifications. MS²Rescore is developed at the Compomics lab at the University of Ghent, and it's shipped with Mascot with the permission of MS²Rescore developers. MS²Rescore includes two components. DeepLC predicts the retention time of a peptide from its sequence, charge state, and variable modifications. When you enable DeepLC in Mascot, the software computes the difference, or delta, between the predicted and observed retention time for every peptide match. The delta of correct matches will be around 0. For incorrect matches, the delta will be randomly distributed across a wide range. This kind of clustering is perfect for Percolator's semi-supervised learning. This scatter plot shows observed versus predicted retention time for peptide matches at 1% false discovery rate. When the model is a good fit to your data, the predictions will fall on the diagonal line. MS²Rescore also includes MS²PIP. MS²PIP predicts the fragmentation spectrum, including peak intensities, based on the peptide sequence, charge state, and variable modifications. When you enable MS²PIP in Mascot, the software computes a correlation between the predicted and observed MSMS spectrum for every peptide match. The correlation for correct matches is typically very high, like 0.9. But for incorrect matches, the correlation will be randomly distributed between 0 and 1. This kind of clustering is perfect for Percolator's semi-supervised learning. This histogram shows the spectral correlation for matches at 1% false discovery rate. Again, when the model is a good fit, most of the predictions have a very high correlation. Here's a quick example of the typical improvement. This is a small run of a yeast sample from the CP-TAX study. The sample was measured with a thermo-Orbitrap instrument with 2.5-hour gradient, and it has about 8,600 MSMS spectra. Mascot Server 2.7 and 2.8 identify about 2,700 unique peptide sequences, which map to about 760 protein hits. Version 2.7 doesn't quite reach 1% sequence FDR due to certain bugs with thresholding when rescoring is enabled. In Mascot Server 3.0, when you select a suitable DeepLC model and a suitable MS²PIP model, we identify 24% more unique peptide sequences. This translates to an additional 100 protein hits, a 13% increase. We're seeing similar improvements across all instrument types and all experiment types. Large datasets typically get an even bigger increase than shown here. In the new version, machine learning is much easier to use. The nose-to-tail workflow starts from the Mascot search form. There are new controls for refining results with machine learning, shown here, and you can select the DeepLC and MS²PIP models directly in the search form. The settings are carried automatically to the protein family summary report. The rescored results can be easily exported as MZ-identML, MZ-tab, Mascot-XML or Mascot-CSV for downstream processing. If you use Mascot Daemon, the workflow is the same. There is a new dialog box for machine learning settings in the Daemon parameter editor. Tick the box and select the DeepLC and MS²PIP models. In the Daemon auto export form, choose an export format like MZ-identML. And that's it. When you click Run, the machine learning settings are passed through all the way to the end. Mascot automatically refines the results with machine learning, and the rescored results are automatically exported as MZ-identML. When you update to version 3.0, one question is what happens to your existing search results? After updating, you can refine existing results immediately. The search does not need to be repeated. Simply open it from the search log and select DeepLC or MS²PIP model in the report. If you're in the middle of a project, updating to Mascot Server 3.0 is safe. Machine learning is entirely optional. Until you enable it explicitly, your existing research results are not changed. Refining results with machine learning often gives a big improvement, but it's not infallible. Many things can go wrong. How do you know it's working correctly? In Mascot Server 3.0, you don't have to blindly trust the software. We provide a machine learning quality report, which takes the guesswork out of machine learning and shows you what happens behind the scenes. The report includes plots like the score comparison of target and decoy matches, the relative importance of each feature like predicted retention time and precursor mass error, and various DeepLC and MS²PIP model performance metrics. Machine learning isn't the only improvement in Mascot Server 3.0. We have also added new controls for the error tolerance search. The Mascot error tolerance search is a two-pass search for identifying unsuspected modifications and semi-specific cleavage. The first pass is an ordinary database search. The second pass begins by selecting proteins with a significant match for further searching. Mascot iterates through a modification list and identifies unsuspected modifications on the selected proteins. In the new version, you can now constrain the second pass to selected modification classes. These are classes defined in the Unimod database. For example, if you only want to search for N-linked glycosylation and artifactual modifications, choose these in the search form. The numbers in parentheses are the counts of modifications in each class. In this example, Mascot will search 36 N-linked glycans and 136 artifactual modifications in the second pass of the search. The user help shipped with Mascot has been thoroughly reviewed and updated. All the content has been checked for accuracy. Dozens of new help topics and tutorials have been added. For example, details about Mascot scoring, machine learning, automation with Mascot Daemon, and a lot more about quantitation with Mascot. Mascot Server 3.0 includes Mascot Daemon 3.0. You can enable and set machine learning options from the Daemon parameter editor, and you can also select the Unimod classifications for the second pass of an error-tolerant search. Mascot Daemon now ships with Mascot Daemon Export Extender. This is a script that allows automatically running distiller quantitation reports at the end of a task. For example, you can configure Daemon to produce a CSV table of peptide ratios or an ANOVA report. When you create a quantitation summary report in Daemon, you can now use the top 3 average intensity for proteins. Deleting a large number of tasks from the Daemon task database is now much easier. Simply select the range of tasks to delete and click to delete. Also, if you use the Distiller Daemon toolbox, the toolbox is now aware of processor groups on Windows 11 based systems. For example, if your system has 96 logical cores, Daemon 3.0 distributes peak picking across all 96 cores. And finally, Mascot Server 3.0 introduces a new file format, Mascot Search Results, or MSR. This is a self-contained SQLite database with a formal schema. The new file extension is .msr, and it replaces the old text-based .dat format. The reason we have designed a new file format is to increase the performance of reading and parsing search results. The new format reduces delays when browsing search results, and it also makes exporting the results a bit faster. More performance improvements are planned in future versions of Mascot. Mascot Server 3.0 retains high levels of backwards compatibility. It's a drop-in replacement to earlier versions. You can view and export all your existing results from any previous version of Mascot. The procedure to submit a search and exporting results is unchanged. You can export MSR files in the old format if your application requires it, and you can even force Mascot to write all the search results in the old format. The client API is unchanged, so all existing application programs should continue to work normally after updating to the new version. There are a lot more improvements that we haven't covered here. The full list of changes and improvements is on our website. Go to matrixscience.com, click Help in the main menu, and then the link What's New in Mascot Server 3.0.